Okay, in this video we're going to look at some algebraic and graphical methods to solve inequalities. And the first example we'll take a look at is, first of all, we're going to solve these inequalities first by factorizing and then sketching. So example A, x squared plus 6x plus 8 is greater than or equal to 0. And we'll take a look at that one first. So we had x squared plus 6x plus 8 equals, oh, it's not equal to, it's greater than or equal to 0. Okay, so we'll find first of all where the quadratic crosses the x-axis its solutions. We'd factor it x plus 2 and x plus 4 is greater than and equal to 0. So if I was to sketch that one, I would see solutions at -4 and -2. So just a quick sketch. And do something like that. That's not a great sketch, but it's good enough for our purposes here. -2 and -4. Okay, we're looking for the range of values of x that will yield greater than or equal to 0 values in y. So in that case we will have two ranges. So we'll have from -infinity up to and including -4, up to and including -4. We'll just put that in closed notation, together union -2 up to and not including positive infinity. So we could just say, without using set notation, x is less than -4 or x is greater than -2. And we'll just take a look at the second example, and in a similar way we will find the range of values that satisfies 2x squared minus 11x plus 12 is less than 0. So we had 2x squared minus 11x plus 12 is less than 0. Now I just want to factorize this one. So I'm looking to say two numbers, when I multiply them will give me positive 24, and when I add them together will give me -11. So that's going to be -8x and -3x plus 12 is less than 0. Just a little practice on factorizing when we've got a value of a which is 2. So we'll take 2x on x minus 4 minus 3 on x minus 4 less than 0. So the factors would be 2x minus 3 on x minus 4, and all of those are less than 0. So the critical values are the values, the solutions of this quadratic that we're interested in is 3 over 2, x is 3 over 2, and x is 4. So if I was to quickly sketch the quadratic, do it over here, we've got a quadratic is going to maybe look a bit like this. and the value we're interested in, 3 over 2, positive 3 over 2, and positive 4. And our inequality is asking us to find the range of values of x such that the curve will be negative. So it's all values of x lying between 3 over 2 and positive 4, but not including either. So the range of values of x will be 3 over 2 is less than x is less than positive 4. Okay, so that's that example complete. We look at example 2. So in example 2, we're looking to find a range of values which satisfies both of the following inequalities. So the first inequality is x squared minus 3x is greater than or equal to 0. And the second is 3x plus 1 is greater than 2x plus 6. So we're looking for a range of values which will satisfy both. So I'll just move over to the pad and note the problem, the quadratic first. X squared, do that again, x squared minus 3x minus 4 is greater than or equal to 0. And if I was to solve that, I'll just go x minus 4 and x plus 1 is greater than or equal to 0. So it'll give me the values x must be less than or equal to minus 1, and that is together with values of x must be greater than or equal to 4. I didn't bother sketching this time, we did so in the last couple of examples. So those are the values, the range of values of x that satisfy the quadratic, and our linear equation was 5x plus 1 equals, no, not equals, is less than, I'll write that again, 5x plus 1 is less than 2x minus 8. So bring the x values to the left. 5x minus 2x is less than minus 8 minus 1. So I have 3x on the left is less than negative 9, and 3x, x therefore is less than negative 9 divided by 3 is negative 3. So we're looking for the range of values that satisfies both. So I'll just take a look at this. To satisfy both, I need to look at all values of x less than negative 3. Satisfy both. Okay, so let's go back and look at the last example. And the final example we have is we're looking for a range of values which satisfy both of the following inequalities simultaneously. And that's x squared minus x minus 6 is greater than or equal to 0, and x squared, the linear is 5x plus 1 is less than 2x minus 8. So we'll take a look at this example on the notepad, and the quadratic was x squared minus x minus 6 is greater than or equal to 0. And we'll factor it. X 3 and 4, it's going to be negative 4. Sorry, not 3 and 4, 3 and 2. So it'll be negative 3 and positive 2 is greater than or equal to 0. So the range of values that will satisfy that will be x will be less than or equal to -2, or x will be positive or equal to +3. So that's the first part complete. Now let's look at the linear part. 5x plus 1 is less than 2x plus 2x minus 8. Bring the x terms to the left. Is less than -8 minus 1. So we have 3x on the left is less than -9, and x is less than -1. 9 over 3, -9/3 is -3. So in order to satisfy both of these inequalities, I need to just have a look and see. On the left, we've x less than or equal to -2 and x less than -3. So the final answer, which will satisfy both of these simultaneously, will be x less than -3. And that's the end of today's video. So thanks for watching.